Okay, I want to get into the idea of energy conservation and how we use that in physics. And there are a couple of ways we have of thinking about this that are really helpful to get your head around. So let me describe the idea first. So first, in physics class, we'll assume that total energy is always conserved. So we're not creating or destroying energy, but energy becomes less useful. And when it's less useful, like we lose it to friction, then we consider it not really usefully conserved. And so we call this mechanical energy. So mechanical energy is the useful stuff. So if I have it stored someplace like in gravitation, or stored inside a spring, or stored in kinetic energy, that's useful stuff. I can get that back out. So we'll say mechanical energy is conserved when I have energy that moves between those things, moves between a spring or gravitation or kinetic energy, and I can get it back. So this is pretty much, in this class, is going to be in the absence of friction. So if there's no friction, mechanical energy is going to be conserved, and if there is friction, right, total energy is conserved, but not mechanical energy. So let's take a look at what this looks like. So here I've got this skate park. So I have no friction going on here, and gravity. So notice my total energy here. So this bar chart on the left-hand side is really handy. We're going to use the bar charts a lot. So I'm going to start with potential energy, gravitational potential energy, and as the skateboarder hits the bottom, it'll all be kinetic energy. But notice my total energy isn't changing. So it's just shifting. So I have energy in one container, potential, and to another container, kinetic, and back to potential. So when I add friction into this, right, now, notice that I'm losing. My total energy is the same, but now I'm losing that energy into thermal, so it's becoming less useful. So my total energy is conserved, but my kinetic and potential energy, or what I'll call my mechanical energy, is not being conserved, and so I'm losing some of it. So I'm going to be careful about how I describe some things. So energy, we'll have conservation of energy, and we can pretty much only lose it through friction in this, friction and drag. So there are a couple of handy ways of thinking about this. So here's another example. And again, I like these bar charts on the side as a way to describe this. So what I'm going to do, start this thing in oscillation. So it's going to be moving up and down. And notice my total mechanical energy is going to stay constant. So right now, this is all gravitational potential energy. And as I run it, that's going to shift. Now I've got some spring energy and a little bit kinetic, and then spring and gravitation. Now, if I look at these three separately, right, so my spring energy, that as my spring gets stretched, I'm storing more energy there. As it goes higher, as my box goes higher, I'm storing more gravitational potential. But notice these three add together to equal mechanical energy. So I'm not losing any energy in this. There's no friction that I'm worried about, no drag, no torsional loss in the spring. That I've got mechanical energy, which is conserved. So these bar charts are a really handy way of thinking about it. But notice there's got to be something to start this in motion, right? So just like with my skateboarder, oh, good grief, she's got to stop. Right? My skateboarder, I had to get her someplace, right? So how did I start this all? Well, I lifted the skateboarder up to the top, right? So I did some work. I applied some force against gravity along some distance. So I applied some force over some distance to get here to the top. So now I put energy into my system. So work is the only way that we have in this class of adding energy into a system, and technically it's the only way that we'll have of taking energy out of the system. So I'm going to think of friction as being some frictional force over some distance that's acting to remove energy from my system. So let me describe a way that we'll think about this. So let me go back to, I guess to the skateboarder, and let's draw something out so we can see how it's going to look. And the way that we use these systems is really handy. So let's see where this goes. Here it is. Right. So this is how I want to think about these. So I'm going to have a before and after. I'm going to say, well, here's my energy that I have before. Right. I can do something to my system, right? And then I'm going to have some energy afterwards. Right. So, for instance, if I have the spring that's moving back and forth, I may start here with gravitational potential energy, and that may move to kinetic energy, and that may move to potential spring energy, right? And my total energy, right, is always going to be the same, right? My total energy before and my total energy afterwards is going to be the same. Imagine those are the same height. And what happens, right? So maybe I start with a lot of gravitational potential energy. I start with all gravitational potential energy when I'm at my top. When I get to the bottom, I'm going to have gravitational potential, kinetic, spring energy. When I get to the bottom, I'm going to have all spring energy. And so this is one way that we like to represent this. So notice what I'm saying. I'm saying that here I started with gravitational potential energy and this much total energy. And then when I got to the bottom, right, so the second thing I'm interested in, it was all in my spring, and I had the same amount of total energy. So there are circumstances where I may be adding work into something. So if I start, for instance, with a car that's at rest, right? So if a car is at rest, I have no gravitational potential energy, no kinetic energy, no spring energy. My total energy is going to be 0. Right? So this is what I had before. This is the energy before. If I push that car, I'm doing work. So what am I doing? Well, I'm taking my system and I'm adding energy into it. So I'm doing work. And I'm going to end up having, at the end of that, well, maybe I just have kinetic energy now. No spring, and my total energy now is going to be higher, right? So notice in this case, after, this is not energy conservation, right? So this is not mechanical energy that I had beforehand being conserved and afterwards, right? So my mechanical energy was less at the beginning, but I added energy in through work, and now I have more mechanical energy. So we're going to have ways of getting to equations, and what I want to do is always start with the same idea. So the energy before is going to be equal to the energy afterwards, and I'm going to take work into account, right? So I can think about this as energy plus work is going to equal the energy afterwards. Now remember this, there it is. So remember the sign of work tells me something. So if I'm adding energy in, I'll have positive work, and if I'm taking energy out, I'll have negative work. So these two are the general forms of the equation that says, well, here's my energy conservation, the absence of external forces, and here's my energy conservation with including external forces that can add or subtract energy from it. And now what I want to do is I want to get to an equation, right? So for this first one, well, what am I doing? Well, I start with gravitational potential energy, right? So that's all the energy I have before. And I end with spring energy. And now I can get to an equation from that if I needed to. And this is what we're going to be doing all the time. So you're going to start here, right? Start with one of these two equations, and then take into account the things that are actually changing this. So, so we're going to see a number of these sort of diagrams. And this is the best, in my mind, this is the best way to think about energy conservation. So we'll end up with a whole bunch, right? So this one, if I'm close to the surface of the Earth, 1 mgh is going to be 1/2 kx squared. And then I can solve for whatever is missing. Right. Let's think about in terms of like a roller coaster. So let's go back to this energy skate park. Where is it? So here it is. So let's make it more complex, right? So I'm going to go here. So I'm going to set friction to nothing because I don't feel like worrying about it, right? So she's going to go along, and she's going to get to some point like here, right? So you got a bunch of stuff going on. So she started with gravitational potential energy. And it gets to this point, she's going to have some gravitational potential energy and some kinetic energy. So let's take this into account. Let's draw this out using the energy diagrams and take into account the situation that she's in right now. So again, what am I going to start with? So I'm going to start with possibly kinetic energy, possibly with gravitational potential energy, possibly with spring energy. And then I can add or subtract work. And then I'm going to end up possibly having kinetic energy, possibly having gravitational, and then possibly having spring energy. And so in this case, she started. I set her up high. I did some work to get her going, but when she's going, she's got gravitational potential energy. And then when she got to that point, she had some kinetic energy and some gravitational potential energy. Right? And these two bars are going to equal this, right? So there's no friction. I didn't add anything out of my system. Right? So this is my energy before. This is my energy afterwards. I'm going to say my work is 0, so I didn't do any work on it. Right? So now I'm going to write out my energy that I start with plus work is going to equal the energy that I ended with. All right, this is 0, so I just started with UG, and this is going to be equal to K plus now my new gravitational potential energy. So I could say mgh that I start with is going to be equal to 1/2 mv squared plus mg nu h. And you may notice that in the absence of springs, right, my mass is going to cancel. So it doesn't matter her mass that we could, if we need to know velocity or her ending position or whatever it is, that mass is going to be irrelevant. So again, in energy, mass often cancels. As long as I don't have a spring, it's probably going to go away. Anyway, this is the way that you want to be thinking about these. Lay these out carefully. Think about energy you might be adding into or subtracting from your system. And then come up with an equation. Every time it's going to be a slightly different equation, but it starts at the same place, which is conservation of mechanical energy, if that's the case. Hope that's helpful. Talk to you soon. Bye.